Hi everyone, myself Satya, Department of Mathematics, SNS College of Technology. So already we are in the same topic, which is graph. So many topics we covered. So in today's class we are going to see basic definitions, path, connected, and based on that we will have the theorem also. That is today we are going to see. Okay. So now we are going to see the definition one by one. After that we'll move on to the theorem. Okay. So the first thing is path. A path which is a path in a graph which is a sequence of vertices. Each should be adjacent to the next. Okay. Then length of the path, the number of edges appearing in the sequence of path, which is called the length of the path. And circuit, a closed path in which all the edges are distinct, is called the circuit. Cyclic, a circuit in which all the vertices are distinct, is a cyclic. Connected graph, a directed graph, and directed graph is said to be connected if any pair of nodes are reachable from one another. There is a path between any pair of nodes strongly connected. A simple digraph is said to be strongly connected if for any pair of nodes of the graph both the nodes of the pair are reachable from one another. Weakly connected. A simple digraph is said to be weakly connected if it is connected as an undirected graph in which the direction of the edges is neglected. Unilaterally connected. A simple digraph is said to be unilaterally connected if for any pair of nodes of the graph at least one of the nodes of the pair is reachable from the other. So a unilaterally connected graph is weakly connected, but a weakly connected is not necessarily unilaterally connected. Strongly connected is both unilaterally as well as weakly connected. Okay. Now we are going to see the theorem. Already we completed 3 theorems. Yes, tell me the statement. Yes. The first theorem is handshaking theorem. The number of odd degree vertices are even. That is second theorem. And the third one is maximum number of edges in a simple graph is n into n minus 1 by 2 edges. Okay, these theorems we already completed. Now we are in theorem number 4. A simple graph with n vertices and k components which cannot have more than n minus k plus 1 whole divided by 2 edges. A simple graph with n vertices and k components must have at most n minus k plus 1 whole divided by 2 edges. Now we are going to prove the theorem one by one. So let n1, n2, etc. nk be the number of vertices in each of k components of the graph G. Then n1 plus n2 plus etc. nk equal to n, which is nothing but the total number of vertices. So summation I equal to 1 to k ni equal to n, and summation I equal to 1 to k ni minus 1 equal to n1 minus 1, n2 minus 1, nk minus 1, which is equal to summation ni minus k, I from 1 to k. Okay, so ni minus 1 equal to n minus k. Now we are going to square the terms both sides. So summation ni minus 1 the whole square equal to n minus k the whole square. So replace I as 1, 2, 3 etc. till k. So n1 minus 1 the whole square, n2 minus 1 the whole square, nk minus 1 the whole square, which is less than or equal to n square plus k square minus 2nk. Now expand the terms a minus b the whole square. So n1 square plus 1 minus 2n1 plus n2 square plus 1 minus 2n2 plus last term is nk square plus 1 minus 2nk, which is less than or equal to some terms. Then you collect all square terms n1 square, n2 square, nk square minus 2 times of n1 plus minus 2n1 minus 2n2 etc. minus 2nk plus 1 is repeated for k times, which is less than or equal to the same term. And generally we can denote this first bracket by summation ni square I from 1 to k, and second 2 times of n1 to nk, which is nothing but n. Now sorry, how many times 1 is repeated, which is k times, so that's why we are putting k, and which is less than or equal to this term, and bring all the terms except the square term in the left to the right, so which is 2 plus 2n minus k. And using the theorem we can use G is simple and maximum number of edges of G in its components is ni into ni minus 1 whole divided by 2. Okay, so maximum number of edges of G, summation I equal to 1 to k ni into ni minus 1 whole divided by 2. So ni square minus ni. Ni square, just bring that 1 by 2 outside. Ni square, already we have the statement in the last. So replace that value. Then summation ni is n. You just subtract, then you get some terms like this. Then we can write the first 3 terms as n minus k the whole square plus n minus k. So n minus k is a common and take the remaining one as n minus k plus 1. So this way we need to prove the theorem. Okay. I think you understand this theorem is very important. Okay. The remaining thing we will see the next class. Thank you.